All right, guys. So we're going to do the entire chapter over again, but we're going to do it in radians. So I would always say that these first two chapters are the key to trig, because if you understand all of this, you're going to understand everything. So the reason why we have radians is if I say 30 degrees, we all know the angle, but if I say, where is 30 degrees on a number line? Here's 0. Where would you put 30 degrees? It's not going to just go over here at 30. 30 degrees is an angle. It's not what we would say a number. So what we need to do is we need to come up with a corresponding real number that corresponds with degrees. So here's what a radian is. If I take the length of this radius and I take that same length onto the arc, so this length here is equal to the radius. The angle that is created right here is considered 1 radian. So the true definition of a radian is when when 1 radius is mapped along the circle. 1 radian is the angle that's formed. Okay, so if I keep going and I go another radius here, that's then this whole angle is about 2 radians. If I keep going, I'm about here, that's 3 radians. Well, look at that angle right there, this 3 radians. It's a little bit more than 3. A little bit more than 3, maybe like 3.14. What would that be? I wonder. Pi. Pi is equal to 180 degrees. And that's something you're just going to get to know really good, really backwards and forwards. Initially, this radian stuff you're not going to like so much, but after you get the hang of it, it goes a lot quicker and it's a lot easier than degrees. You just have to kind of get some practice with it. Okay, so if 1 pi is 180 degrees, think about what it would be all the way around. Well, all the way around is 360 degrees. 2 times 180 is 360, so that's equal to 2 pi. Just always think pi is 180, pi is 180. Okay, so let's go back to the circle. If I make a 90-degree angle, that's half of 180. So what's half of pi? I'm going to erase this because I need space. Pi over 2 is equal to 90. And again, think 180, which is equal to pi, divided by 2 is 90. So now let's take that 90. What's half of 90? Half of 90 is 45. We like 45, 45, 45, 90 triangles, right? What's half of pi over 2? Pi over 4. So when you see a pi over 4, you're going to like that. Why? Because we have 45, 45 triangles. What other angles do we like? 30, 60, those type of problems. Well, how do I get 30? Now let's go from the 180. How do I get 30 from 180? 180 divided by 6 is 30 degrees. When you see a pi over 6, that's 30. That's what you're going to want to think, because what are we trying to do? We're trying to get our reference angles. And then same way, how am I going to get a 60 from the 180? 180 divided by 3. So these angles, you need to know backwards and forwards. Those are huge. Those are very, very, very important. If you don't know these like the back of your hand, you're going to struggle with everything we do in trig from here on out. And all of this is in calculus. So that's why we're sticking to the important stuff that's in calculus. Calculus never uses degrees, ever. Okay? I'm just going to add to this. We also have 270 degrees, which is a quadrantal angle. Well, 270 is 90 times 3. So that's going to be 3 pi over 2. Which really, do you have to memorize that? Not really. Here's 90, right? Pi over 2. 90 times 3. That's 270. Okay, so that's how I want you to kind of think of this stuff. Always remember, pi is 180. If you see this and you say, shoot, I can't remember what's pi over 6, in your mind, plug 180 in for pi. 180 divided by 6 is 3. So we got all of the quadrantal angles and go from there. So these are your important angles. You need to immediately know. Pi over 4, 45. Because I'm going to give you an angle like this. 7 pi over 4. And I'm going to say, what's our reference angle? Immediately you're going to say, oh, there's pi over 4. Our reference angle is 45. You're going to draw your triangle with the 45-degree reference angle. I could ask you for 6 pi over... Yeah, I didn't use a good one there. Let me use 7 pi over 6. I'm going to say, what's the reference angle? Well, here's pi over 6. Pi over 6 is 30 degrees. Reference angle is 30 degrees. It will be in a different quadrant other than quadrant 1, and I'll explain how we're going to figure that out at that point. Okay? So, this first lesson, all you're doing is you're converting things backwards and forwards from radians to degrees, degrees to radians. So let's just do a couple examples here. If I say 400 degrees, convert to radians. Now, 400 degrees is not going to be it's not a nice reference angle or anything like that. We're just doing a straight out converting here. When you convert to radians, we want pi. Think about all the radians, we're going to have pi, or it's going to be an ugly decimal. So if we want pi, we multiply by pi over 180. Anytime you're converting to radians, you want pi, you multiply by pi over 180. So I'm going to take 400 times pi over 180, and I'm just going to reduce this like I normally would. So if you want, just go to the calculator, type that in. I don't really care. Just ignore the pi. I'm going to reduce it by hand. So I'm going to reduce it by 10. And then with 18 and 40, there's a common, what's the biggest number? 2, I guess, is the biggest. So I take 18 divided by 2, 40 divided by 2. So this is 20 pi over 9. So 20 pi over 9 is the equivalent angle as 400 degrees is. So convert to radians, you literally just do a straight conversion, you multiply by pi over 180. Okay, so let's do 320 degrees. I want radians, I want pi, I multiply by pi over 180. And then I'm going to reduce. Again, you can go to the calculator, you can plug that in as a fraction and reduce it. I'm going to reduce it the old-fashioned way. So I divide it by 10, and then I'm going to divide by 6. No, not 6. What am I thinking? I'm going to divide by 2 again, I guess. And so I get 16 pi over 9. Oh, another 9 in the bottom. That's just by coincidence. So this, again, is the radian equivalent to 320 degrees. Okay, if we go backwards, so now we have radians. Let's say I go 9 pi over 4. So I'm going to convert to degrees. I want degrees, I want 180. I multiply by 180 over pi. So look back here. You want radians, you multiply by pi over 180. You want degrees, you flip it. You multiply by 180 over pi. Okay, you just got to think of which one's in the top. When you're converting to radians, you want pi, pi's in the top. When you're converting to degrees, you want 180, 180's in the top. So now I just multiply by 180 over pi. Pi's cancel. 2, I'll reduce it by 2, and then reduce it by another 2. And 9 times 45, what is that? 45. 395, is it? I think so. 405. So 405 degrees is equivalent to 9 pi over 4. All right, now I'll be honest with you, we're not going to do a lot of converting. I don't want you to convert. I want you to see this problem and say, oh, 45 degrees is the reference angle, and then we're going to go from there and try to figure out what quadrant it's in. Okay? In fact, I'm going to do that right now. Let's just look. This is how I'm going to go 3b. When you see 9 pi over 4, I want you immediately to think, oh, the reference angle is pi over 4. You already know the tangent of 45, cosine of 45, sine of 45, but we have to know, is it positive or negative based on what quadrant it's in. So if I'm trying to figure that out, I know this is 0, and I know this is pi. Remember, pi is 180 degrees. Just like with degrees, we never use 90, we never use 270. So I'm not going to use pi over 2, and I'm not going to use 3 pi over 2. When I see the 4 in the bottom here, I'm going to make this a common denominator. So I'm going to make this 4 pi over 4. It's still pi. Okay, this is 2 pi over here. So I'm going to make the common denominator there, 2 pi times the FFU, 4 over 4. That's going to give me 8 pi over 4. So I'm going to go to 3 pi over 4. Let's see what quadrant 3 pi over 4 is. If I start here and I start rotating, I get all the way to 4 pi over 4. I don't want to get that far if I'm only going to 3. I'd be 1 less. You're always going to be either 1 more, 1 less, 1 more, 1 less. So 3 pi over 4 would be right here in the second quadrant. Because if you go all the way to here, you're at 4 pi over 4. What about 5 pi over 4? Where would 5 pi over 4 be? Well, as soon as you know it's a 4 in the bottom, you write this over here. I'm going to clean this up. This is 4 pi over 4. So I'm going to rotate from here. I'm at 4 pi over 4. That's not enough. I need to get to 5. I need to go 1 more. I'm in the third quadrant. Reference angle would be 45, and I can find my trig answer. 7 pi over 4. What quadrant is 7 pi over 4 in? Well, this is 8 pi over 4 over here, because that's 2 pi, and I want the 4 in the bottom. So if I rotate all the way around to 8, I don't want to get to 8, I only want to get to 7. That tells us it's in the fourth quadrant. So can you think about where would 9 pi over 4 be? What quadrant is 9 pi over 4? Well, I'm going to go 4 pi over 4. I keep going. 8 pi over 4. I need to keep going. It would actually be in the first quadrant. It's 1 more than 8 pi over 4. It's always going to be 1 more, 1 less, whatever. Okay, I'm going to do another quick one. Let's do just number 4. This will be the last one we do. We're not going to convert. We're going to find out what quadrant and what is the reference angle. Okay, so I'm going to do 5 pi over 3. Okay, so immediately tell me what the reference angle is. Reference angle, pi over 3, I'm thinking 60. That's the only degrees I want you to think about. Do not convert these. So let's find out what quadrant we're in. This is 0. This is pi. If I keep going, this is 2 pi. I have a 3 in the bottom, so I need to make this a 3 in the bottom. I multiply by 3 over 3. If I reduce it, still pi. I need a 3 in the bottom over here, so I multiply 2 times 3. Because I multiply by 3 over 3, I get 6 pi over 3. So 5 pi over 3. I'm going to rotate here. I get to 3 pi over 3. Got to keep going. But if I only go 1 more, I'm only at 4 pi over 3. Well, that's not what I want. I want 5 pi over 3. I keep going. 3 pi over 3. Keep going. 6 pi over 3. Oh, that's too many. I'm 1 less. I'm in the fourth quadrant. So what if this were a problem and it would say the sine of 5 pi over 3, I would know I was in the fourth quadrant. I draw my triangle out from the origin to the x-axis. Reference angle is 60. Label. Sine is opposite over hypotenuse. And all students take calculus. This is going to be negative. And so that would be my answer. Okay, that's all we're going to do today. So technically, you're just converting today. But I wanted to show you some of this so we could kind of get going a little bit more on that. All right, good luck.